Okay, in this video here, we're going to analyze a detail on a building. Okay, so this building's about probably, 10 or 15 years old. And, there'd be some challenges, I think, building it this way, the way it's detailed, with the current energy codes. But we'll analyze it nonetheless and see if we could find a better approach to some things and really just talk about all the components that are visible in the detail, and then maybe that'll help people understand what they're looking at when they look at a technical detail and what type of information is shown in a technical detail as well. And so the detail is a 2D detail on the left, and what this is looking at is a section through here, like this, okay? So, just a quick glance, we have a door here, so that would be this component right here. So again, I'll get into this in more detail. There's the edge of a floor slab right there. That's this face right there. Okay, there's 8 or so courses of brick between there and there. And that's what we're seeing between here and here is the brick. Okay, and then of course the window down here, which would be this window right here. Okay, so for starters, let's work our way through this detail. I'm going to start with this structure first, and then we'll look at the substructure. Then we can maybe look at our thermal control layer and our air, vapor, and moisture control layers and finishes and whatnot, so gypsum boards and our openings, claddings and guardrails, all that kind of stuff. So we'll start with the structure though. And if the detail looks faded out, by the way, it's because I put a filter on it so I could draw on top of it and it'd be more apparent. Okay, so what I've drawn here is the main superstructure of the building. So this is a concrete building. Okay, so it looks like a 250 deep concrete floor slab, and they've added a curb here just to raise the door off the floor level there. And so that represents our superstructure. So it's a concrete superstructure of this building. Okay, next I'm going to focus on some steel that I see in here. So I see some lag bolts in the concrete here. Okay, that tells me there's probably a piece of steel hanging down here, and I'm seeing some dashed lines here and something over here. I'm seeing a steel angle over here. So what we've got here is probably, this isn't my detail or my building, but there's probably a steel plate cast into the concrete right here, okay, with some lag bolts on it. And then there's a steel HSS tube probably welded to that plate and extending down to this point right here. Okay, so I've highlighted that in blue. So that would be like a steel HSS tube, piece of steel welded to a plate hanging down from the concrete structure there. And just to give an example of that, it'd be something like this. So, there's a concrete floor there and then steel tubes hanging down. You can see the weld plate there. Okay, so the plate's been cast into the concrete. There's some extra plates here, which obviously they're not using yet anyways in this building. Not the same building, but it'd be a very similar situation. And then they're coming in and welding the HSS tube to that weld plate. So that's what those dashed lines are representing. And now the reason that's there is because there's 8 bricks here, and bricks are quite heavy, so we have to support those bricks with I like to call it secondary structure. So the superstructure of the building is the concrete in this case, and this steel would be considered like a secondary structure element, which is needed in this case to support the heavy bricks, so this type of cladding. Okay, so there's the steel angle in section right there that I've highlighted in blue. Okay, and what that looks like in real life. So again, not the same building, but there it is right there. So there's the edge of that steel angle right there. Okay, and there's the brick resting on that steel angle. So the steel angle is going to carry the loads back to the superstructure. So in this case here, so here's the steel angle right here, and it was below the actual concrete of the superstructure. So they need to attach it back to the superstructure. So in this case, they've put a weld plate vertically in this building and put a small HSS tube welded to that weld plate there, extending down, and then this angle is welded to that. And now, so this steel angle has to attach to this steel tube coming down here. So what they've drawn here is a knife plate, which is going to be welded to this, or bolted in some fashion, welded to that, and then welded to the steel angle, or again bolted in some fashion. So I'll highlight that. And so there's that knife plate, the way they've drawn it in this detail. So, it could have just been a rectangle piece in here. They've taken it taller and put an angle on it, and that looks like they've done that so that the flashing can go over top of it and give a shape or form for the flashing, basically. But that, anyways, that would be the secondary structure there, which is that all that's needed just to support that brick. I guess I should say it just supports the brick. The other thing I would be doing here as well is there's an opening here. I'll get to this in a second, but there's some steel stud framing in here. And, this steel stud framing, um, the farther it hangs down, the less resistance it's going to have to wanting to, I guess, bend in those directions there. So, framing between the drop down steel is going to give rigidity to that steel stud that's just hanging basically from the top of the or from the underside of the slab there. And of course, do you need that always for when you're hanging down steel studs? Not necessarily. If this window wasn't too big and there was continuous studs on each side of the opening, then and the opening wasn't too wide, then it would be okay probably. But nonetheless, it could be offering some more structural support there than I first mentioned. And just to get an idea of a knife plate situation, so here's a steel angle. This one's turned the other way. It's turned downwards, but there's a steel angle nonetheless. And there's your knife plates back there. So in this case, they've done two knife plates, it looks like, on this building. So they've got a steel HSS tube here in the background, and they would have had a plate coming off of that. Okay. And then they've had a plate welded to the back of this angle, which then bolted the two plates together. And so just another picture of something similar. So here's the steel angle. It's kind of like this. It's hard to see there, but the leg is up like that. And anyways, and there's the knife plates going back to the superstructure. And what this does is this, by doing, rather than taking the angle all the way back right against the concrete like that, that would be a continuous, piece of steel going through the insulation plane, which will be on the outside of this building. So by pushing the angle off and just doing that, you can now get insulation in behind the angle, and the only thermal bridging you have is at the actual knife plates there. Okay, so we got our superstructure, we got our secondary structure. Now let's move into our substructure elements here. And so what we've got here is there's a track right here. Okay, so it's a top track of a steel stud wall. There's a bottom track right there. Okay, and then there's vertical studs run between those tracks. Okay, and so I've highlighted the studs here in pink. And so here's a picture of something that would be very, very similar. So a concrete superstructure, and if we look closely, there's probably some steel HSS tubes hanging down right there. There's one there. Okay, so there's that steel HSS tube that was welded to the underside of the concrete, and now the steel studs are being put in between this member here and the other side of the concrete and framing around that tube. And so what you'll see here is the top track right there, and here's the bottom track that the vertical studs are going to slide into. And so back at this detail here, you'll notice there's a gap between the top track and the top of the stud right there. So there's a space right there. That's intentional. It's called a deflection track. And what that allows is, between this slab, it wouldn't be so bad for, a floor, but for a roof, for example, there's a slab between columns. And, if there's a heavy snow load or whatever, once there's a load on the floor, that slab will deflect between the support points basically, and so this allows for some deflection to occur without crushing the wall basically. So the top track would just slide up and down over top of the stud here. So that's what that space is for. There's less deflection to worry about obviously in concrete, but when you get into steel construction, again, based on the span the beams go in or something like that, deflection can be, it can easily get up to 3/4 inch, but your engineer can help you with what that deflection would be. But you always want to make allowance for deflection with the architectural elements. So that's what they've shown right there. And what that deflection track typically looks like is something like this. So it's just a slotted top track. So there is a screw that goes into the vertical stud, but they can just slide up and down as the structure deflects. Okay, so that would be the framing for the substructure there. I'll also take a look at this right here. So there's some wood block in there. I guess that's kind of part of the substructure. So that just provides a nailing element for the window or door opening to go on. Okay, so I've highlighted that one there, and then down here there's also a wood block in there. So, that's more like a shim. The window, or the opening, I should call it. I don't know if it's a door or window, whatever it is. Um, when it's manufactured, it's going to be a wee bit smaller than the rough opening that was measured on site. So there's going to be some shims to get it, squared up and nice and plumb. So that's what that would be there. I actually usually always line um, all my rough openings with a plywood nailer, basically a 3/4 inch plywood nailer. I'd put across there, but anyways, we'll just leave that the way it is. Okay, next here we'll take a look at the sheathing that's been put on the studs and the gypsum board on the inside. Okay, so I've highlighted the sheathing and gypsum boards in green here. So there's a glass mat sheathing. So this would be a non-combustible building, so it wouldn't be plywood, or it wouldn't be OSB board. It would be a glass mat sheathing, which I'll show a picture of in a minute. And then on the inside here, they've got gypsum board. If we move up here, oops, there's a gypsum board here on the inside. Okay, so down here, they've attached the gypsum board to that stud framing. They've attached the sheathing to the stud framing. You always want to look at what are things being attached to. And so up here, they've put in what's called a hat track. So these are just smaller metal hat tracks that gypsum board's being attached to. And so here's a picture of some steel studs and the glass mat sheathing being applied to it. So this is just one brand. This brand's yellow. There's another brand that's green and another one that's white. But anyways, it's a gypsum board product with a fiberglass facing on it. And it's commonly used in commercial construction. Even if it's not a non-combustible building, it's commonly used as an exterior grade gypsum board. And these hat tracks here, just to show a picture of those, they look kind of like this. This is in a different application, but they're just a metal hat track there that the gypsum board can be screwed to. Okay, so that kind of summarizes the substructure, I think, is pretty much covered there. Next, let's move along to our openings here. So what we're seeing here is this is actually, it's not like a curtain wall frame. This is called a window wall frame system. And here's the glass here. So this is a double glazed system on this one here. So there's one pane of glass, which it would be 6 mil, 13 mil airspace, and then 6 mil glass. Okay, so I've highlighted the glass there. So this would be a double glazed sealed unit, basically, is what's in there. So, we're seeing the 2 panes of glass, and there's a spacer bar in here and whatnot in this glass sealed unit. Now, every manufacturer is going to vary a little bit, as far as their frame profiles, but I can see roughly what's happening here. I'm not familiar with this one in particular, but let's just do a really quick lowdown of how these window wall frame systems generally work. So first of all, what is a window wall versus a curtain wall? So a curtain wall is a glazing system that's hanging off the building, hanging off the structure. It doesn't have to be installed that way. But basically when you look at a glass office tower, it's going to probably be a curtain wall system where you have that look of pretty much full glass. It doesn't always have to be glass panels in there. There could be other panel type systems in there, aluminum or composite metal panels or what have you, instead of the glass. But generally speaking, it's this entire exterior wall system that's hanging outside the structure. That's your curtain wall system. That's not what we have here. A window wall system is generally used, I've pretty much only seen them used on multifamily residential projects for the most part. And what they tend to do is they mimic a curtain wall system. And so here's a sample of a curtain wall system where you'll see the frames of the the aluminum frames. There's the vertical ones, there's the horizontal ones. They're hanging off the structure in this building. Okay, so they're being attached to the structure in some way, shape, or form, but they're hanging off. And then glass panels. This one here looks like it's going to be an office building. So there would be probably what they're doing here is putting What you're seeing there is a spandrel panel, so there's an insulation in there with a metal back pan to it. And this will just be a solid like color, basically a solid panel in front of that that you can't see through because you don't want to see like in the ceiling space and in the beam and all that kind of stuff. And then what'll happen along this row here, and this row here will be probably the vision glass where you can see through it. But anyways, that's a curtain wall system where it hangs off the building. So the window wall system, and so the window wall system looks like a curtain wall system. So it looks like you have a full glazed panel system on this building. Okay, so right here, which you do, but it's not actually hanging off the structure. There's actually panels on each floor that is spanning between the floor structure. So there's, in this case, there's what do we got here? It looks like there's 1, 2, 3, 4, 5, 6, 7 essentially separate panels there. And again, they're framing between the floor structures. And so just looking at some manufacturers literature here just to see the difference. This is a curtain wall system we're looking at here. So here's the edge of the concrete floor structure in this case, with a connection to basically this is the back of the vertical mullions. So from there to here is the vertical mullions hanging outside the structure, and that's just the connection to hang it off the structure. So that connection would happen pretty much at every floor level. Sometimes there's girts in between floors if you're going multiple floors or what have you. And then if we look at a window wall system, the primary difference is in this case that this would be your concrete floor structure. And you'll see that the frame system is, that's the frame there and that's the frame there, it's not outside the structure. It's sitting on the structure, and what happens here is there's a panel that just goes between that frame system. So, in a nutshell, I mean, it's just a less structural capable system. So, these window wall systems can't span great lengths like you can with a curtain wall system. So from the outside, looks like the same thing, but it's not quite the same thing. Okay, and so how these window wall systems generally work, oh, that's a silicone glaze system. Let's not look at that one. Okay, here we go. So this is pretty much a standard type window wall system. So again, here's the floor structure right here. So that could be concrete, let's say. And what you get here is there's a track that goes in here. So, there's some nuances to that track, but essentially there's a track that gets fastened to the underside of the structure. And then the window frame essentially slides into that track. Okay, so the track top and bottom, there's the glass in this case right there. And so that's kind of the system. There's a track, and then, then the window frame and glass system slides into that. And really you're only, you're really relying from a building envelope standpoint, what you're relying on in this system is pretty much that seal there and that seal there. Now you can put compressible insulation in here and that type of stuff, but really it's heavily dependent on that and that. So you do see a lot of these buildings where that system's used, and it really that your building envelope is pretty weak point basically. A top of slab and bottom of slab in these systems. But anyways, I call it a mock curtain wall system. And like I said, it's generally used on residential multifamily projects. I haven't really seen it used anywhere else. And I think part of that is, the floor-to-floor heights tend to be a little bit less for residential, and so this system's it's made primarily for that residential floor-to-floor height situation. And so here's a building here where this is the actual top track being put in place right here of the window wall system. Okay, so the glazing system is going to wrap around and go back into here, and there's going to be a balcony here, obviously. So the exterior wall, so yeah, I guess what I'm kind of saying here, your exterior wall is essentially reliant on those seals that go along that track right there in this window wall system. And oftentimes that goes around the entire building, and that's it. And then interestingly enough, when you get to the lower levels of these buildings, if they're mixed use, there's a larger floor-to-floor height. And usually what you'll find, not always, it depends, a window wall system could work. But in this case, for example, this is the exact same building as the one we were just looking at with the track. And on the main floor, they're actually using a curtain wall frame system because it's got a greater spanning capability. Just more of a commercial grade type frame system. So I'm not sure, what the limitations are to the height of the window wall systems. I'd have to dig into that, but maybe this floor-to-floor height was too much for that window wall system. So here they are putting in a curtain wall frame system, which can get a much greater span height. And there's just an image of that window wall system going in afterwards. Okay. So anyways, back to our detail here. So what we're seeing here is, this one's a little bit different than the manufacturer I was showing, but essentially it looks to me like this is the top. Oops, let's change that. It looks to me like this is the top track here. Okay. Which looks like it gets fastened in right there. And then they've got another component to this which goes like this and clips into the frame there, it looks like, and that's fastened there. So I'm not seeing where the thermal break is on this. I guess it's there, where these are actually two different components. That must be a thermal break on that. Anyways, if we compare that to the one we were looking at here, that top track here, it's a little bit more obvious that it is thermally broken. It's right there. There's a thermal break on that. So, that'd be like a rubber or plastic, just some low conductance material that's hard, where, this side of the track clips into it and this side of the track is separate, so you don't have aluminum going through there. So that's how they thermally break frames, basically. They're not quite as apparent in this one, but I guess it's maybe there. I'm sure what was installed was specified as thermally broken. And then then the rest of this frame is, so the actual frame holding the glazing is, roughly, it's a bunch of pieces to this, but in a nutshell, it's kind of like that. That's the frame. And again, that the blue's the glass there. It looks like there's some finished pieces that get put on here, like so. And looks like this track here looks like it goes down, and then this track clips into it. And there's all these little components, but there's the seal on the inside. There's the seal on the outside. Here's the thermally broken part of the actual window frame. Looks like it's through there. One thing I'm not too sure of in this detail, I'm not sure what this piece is right there. It's not a flashing, pre-finished window flashing. So like the finished flashing is above that. And it looks to me like they got another piece of something going there that's fastened down. I'm not 100% sure what that is. Oh, you know what it might be actually? No, I don't know what that is. Don't know what that is. Anyways, nonetheless, they've got this from some manufacturer, but not sure what's going on there. But I understand the need for the flashing here for sure. I just feel like they've doubled it up. I kind of wonder if that flashing just needs to be, something like, something like this instead. However, I'm going to erase that because there's more I want to talk to about that. Okay, but anyways, in a nutshell, it's kind of the window wall frame system there. Up at the top here, same kind of idea. I won't highlight all the components here, but there's a, well, let's do it. There's an element here that works as a back dam right here. Okay, so this is fastening down to there, but it also fastens to the frame right there. And then the frame system itself is, this roughly something like this. Okay, so there's the frame, and what this back dam element here does, it allows the membrane layer, so the moisture membrane layer, to come up the wall, go onto the sill here, and then up that back dam like that. And then that way, if there's any leaking through this window or door system, whatever it is, if any water gets down into here somewhere, there's a moisture membrane here that'll kick the water out, and it can't, it won't go back in that way because there's a dam there. So that's a good thing to have on every windowsill or door sill situation where possible. If you really wanted to step it up a notch, you could slope this right here, and you'd have to use a leveling shim for the window, but you could slope the top of the blocking there and then put some leveling shims in there, but that would, obviously use gravity to your advantage and then run the membrane up on the slope. But nonetheless, what they got there it's okay. Okay, so I'm going to erase the membrane layer for now. But that's kind of what we're looking at there. Some other components here to this. Looks like there's a flange there where you can tuck this flashing in here. But anyways, that's the window wall systems in this case. Okay, so next, let's take a look at our insulation of this building. So this is a fully outside insulated approach, okay? So there in the green is the outside insulation. So again, there's not very much there. I didn't check the wall tag to see what that is, but it looks like it's maybe 75 millimeters there. My brick is 90 deep, so yeah, it's about 75, so 3 inches, which was normal, 10 years ago or so. Now that the standard essentially is 150 millimeters, so 6 inches would be the standard now, or more. But yeah, I'd say more often than not, what I'm seeing around town right now is 150 millimeters of outside insulation. Okay, and so there's the insulation on the wall below. There it is up above in front of the curb. So now we can start to see that, oh yeah, we got a pretty big problem here. A big thermal bridging problem here. So there's no insulation through the concrete right there. It's been broken. And so what would happen here? Okay, so if it was, say, minus 25 outside, and it's plus, I don't know, 22 on the inside right here. Very, very likely, I would say, in this case, that condensation would start to form on the concrete right there. Because that would be cold enough, probably, because of this thermal bridge through there. I would say that probably there would be condensation happening right there in that concrete. I'd love to get in this building and see, but I'm quite confident of that, especially for prolonged cold snaps where it's cold outside for a long time. And so that's not good. So how is that dealt with? Well, sometimes I've seen this, and I'm not saying do this, but I have seen situations where you frame down, a gypsum board. I'll just draw it like this, gypsum board finish, like so, right here. You'd frame it down with, I mean, it wouldn't do you much good to put metal studs in there, but you could frame it down with, say, some wood, and then fill that with spray foam, because the spray foam then would act as a vapor barrier, and it would prevent any warm, moist air from ever touching that cold surface. And by the time it got to here, the surface of that concrete, so that usually about 300 will do it. But by the time you got, I can't write very well on here, but by the time you got to the concrete here, it'd be warm enough that you wouldn't have condensation occurring. But that's garbage in my opinion. That's a pretty terrible solution to the problem. But I have seen that done, and then and also on the inside, you got to think about what you're looking at here. Like it looks like maybe you have painted exposed concrete there, and then all of a sudden you got this little build out there. Often in these buildings too, though, really you'd have to take a look at what's happening with the ceiling in here, but it's quite often on these exterior walls. Mechanically you'd have to see what's happening, but there's often a duct in here, okay? That's blowing air. out in front of the openings. And so in that case, maybe there is an opportunity to put some spray foam in there. But again, I don't think that whether there's a duct or not, I think there's better solutions to that. So let's just delete that. If this was a real balcony, so let's just say that concrete extended way out like this, and it was a real balcony with a, a slope on it and a railing out here. Let's just say we had that situation. Then right here, there's a wonderful product you can get, a balcony thermal break. And that looks something like this right here. So it's it's just like a styrofoam insulated box with the stainless steel. Well, I guess the stainless steel only extends partially through, but a bunch of rebar going through it. And the reason stainless steel is used is because it has 30% less conductance than regular steel, because you'd still have the steel going through there. So there it is in section. So there's the balcony there. Anyways, you just cast this thing into the concrete, and it, I would say 9 times out of 10 for your basic balcony situation in a concrete building, this product would work. Okay, so back to this here. So, if a person was to use that balcony thermal break product, the one thing you'd want to do is make sure that that styrofoam box, and I'll show that as the rebar there. Let's just say those are the rebar. They go quite far, by the way. I don't know what the distance is. I'd have to look, but they do extend quite a ways. But you'd want to just make sure that the insulated part of that thing is aligned with the insulation above and below, right? That's the whole point, to get that continuous thermal control layer. Now back to what we really have. We don't really have a balcony there. So, if you were to put in that balcony thermal break product, I mean, you'd be left with just a bit of concrete on the outside, so the rebars would be sticking out. So that probably wouldn't work. However, you could probably cut the rebars off and just support that. But this is already a hint to how we can solve this in a better way right here. Okay, so let's just take a look at this picture. And obviously, the design of this building was to see that. Okay, they didn't want to take brick up to there. The designer wanted to see that. Okay, so in this case, I would just say probably the best approach would have been just to fake it as a floor edge. And so what I would do is bring my concrete back to here, like so. Line it up at the face of the sheathing. And basically I would do something like this. So I would do a precast piece of concrete that's just going to be installed just like the brick. Okay, so instead of bricks, you're just going to have a precast piece of concrete. To see something like that, it would just look something like this. Not sure why my picture was all blurry there, but anyways, it's just a precast piece of concrete. That could have been brick or a block veneer or something like that. In this case, they just formed a precast piece of concrete. So that is an option, and you'll see that there's the joints between the different panels, so it's not going to be continuous because again it's precast and they're putting it in there. So that could that would appease from the outside looking up at that. That would appease the design intent there. Okay, you see the 8 bricks and then you see the concrete. But I wouldn't be done there. There's still problems with this concrete. So one way to step this up a notch is, and actually let's take a look at the picture because probably this is happening. What's happening right now is with the concrete coming out to here, and there's a ledge here. This ledge is going to collect a bunch of dirt and grime and crap. It's going to rain, it's going to snow, and melt's going to happen, and it's going to run down the face of this thing right here, and that staining, it's going to stain down the front of here, and it's going to go right onto the brick surface and stain the brick. Okay, so one of the basic rules is to get a drip edge on there. And so how this could be greatly improved is to, do a precast cap like this, get a overhang right here, okay, and get a drip edge in there. And then that way when all the dirt and grime is coming down here, it'll be forced to drip off and not just run down the face of the brick. So 2 things are going to happen the way it is right now. There's going to be staining down the brick. Let's just see. There's my picture's not really clear enough, but there is. I can start to see some staining on the brick there. And the second thing that could potentially start to happen here is efflorescence in that brick. Okay, too much moisture in the brick. and it'll bring some salts out from the mortar or from the concrete itself, or even from the bricks. And so here's a picture of efflorescence happening right here. So this concrete cap they put on here doesn't have a drip edge, and anyways, there's moisture happening here, and too much moisture, and they're getting efflorescence happening. So it's the white stuff that you see on brick. And so here's another example of some staining right here. So this is kind of interesting. This is I can't remember the year of it, but it's quite old, this portion over here. And they got the windowsills and brick or whatever, and there's no staining. It's looking pretty good. Okay, and then they did an addition, I think decades later, they built an addition here, and they tried to obviously match some of the design of the original building, and they did the concrete or stone, one of the two sills there. And it looks like they have the overhang, but they forgot the drip edge, and look what's happening. So they got it right in the old days, didn't get it right in the new days. It's not the way it's supposed to work. So that's a good example, though, of the power of a drip edge. Okay, and so it sounds pretty simple to add this, but it creates complications. So you probably wouldn't want to attach the railing to the front of that anymore, because again, this would be axial loaded onto the brick right here like this, and the loads are going through the shelf angle to that steel there, which I guess is transferring it then to the superstructure like so. So it wouldn't be a good idea to put a railing on the outside of that, obviously, because if you pushed on the railing, it'd be pretty easy to start to wiggle that loose. So you'd have to deal with the railing for one thing. I wouldn't even recommend putting the railing on the top of that. I think that's not a good idea. So we'll deal with the railing here in a minute, but the other thing I've added to this as well, which I think was missing in the original design, is this flat spot right there. So don't make flat spots, just slope, get a slope. Drain, use gravity to your advantage and drain this thing. So I've also put a slope on the top of that precast concrete element. Anyway, so what this has done now is it allowed us to continue the insulation up right there. Okay, and so for your brick veneer systems, and again, this precast concrete's just replacing the brick essentially, so it's part of that brick rain screen system. So usually you put vent holes at the top of brick and then weep holes at the bottom. They've shown the weep holes here, it looks like. In this case here, you could put the vent holes in the precast panel joints, like between the precast panels just near the top, but probably what I would do is just put them in the brick right here, and that would suffice, I would think, in this case. And the reason I'm suggesting that is because the precast concrete element, actually in that case there, if we look at the picture we're dealing with, it would just be one element, probably. It wouldn't even have a joint in it, so it's kind of difficult to get some vent holes at the top. So you'd be putting the vent holes in the bottom in this case, or I should say in the brick, top brick in this case. And when you're working through a detail, like, it's still not done. Like, we still have some things to deal with. So we've talked about the railing, but somebody might step outside this door and step onto this. Is that okay? You'd have to assess that and wonder, could that be problematic or not? Is a regular, well, doing a brick tie, you maybe have a brick tie on the wall, say, here somewhere with the pin going in here. Is that going to be adequate for this? Probably not. You probably want to pin this back somehow to the wall right here. So we'd have to figure out a solution to that. So there's all kinds of things to work out here in a detail, and you just really want to assess what the situation is and what the challenges are and find solutions to them. Just really quickly, before we get into that, I would run in this case here, I would for sure, at the very least, be running a flashing down here like so. We'll come back to that later. So, the idea of this seemed pretty simple, but there is a whole bunch of other complications now that have to be dealt with, whereas, we did it the way they did it originally. Those problems don't exist, but there's other problems. So you just got to weigh, the pros and cons and make what you feel is the right decision. But anyways, let's just study the brick for a second. Okay, so weep holes at the top. vent holes at the top, weep holes at the bottom, airspace behind, minimum 25 millimeters airspace. This allows air circulation through this thing. Brick's porous, so water could be running down the backside of this thing. It allows it to weep out right here. It promotes drying. And the other thing it does well, if you have, winds pushing on this wall and positive pressure here, having those vents and weeps will pressure equalize that cavity as well. That's kind of the whole principle of a rain screen system. So obviously it's not, it's going to take longer for that to pressurize than a more open joint rain screen cladding system, but the concepts are there. I wouldn't say it's absolutely necessary in this particular situation, but if you read some literature from brick associations, they would recommend a flashing put between the concrete and the brick, and that's just because mainly efflorescence. So the concrete itself could have some salts in it that could migrate into the brick, and then you start to get that efflorescence on the front of the brick. It doesn't always happen, but the potential's there. So if you start digging into literature, you might see some recommendations of that type of situation, of just creating that break basically where the moisture can't migrate from that material to that material there from within basically. So the drip edge is dealing with the runoff on the front, but if the concrete's got moisture within it because it's porous as well as the brick, then it would help alleviate that. And again, you just have to assess that, like, is that okay to see that flashing edge there? Maybe, maybe not, up to you. I've seen many brick walls, or brick put into walls where it has not been an issue and there's no flashing necessarily, but it is recommended. And so I've shown this picture before in some other videos, but here's an example of a brick wall, and there is our vent holes right there. And at the bottom is our weep holes right there. So it's there, there, there. And this line is the shelf angle holding the brick basically. So there's a weep hole on the top and a vent hole on the underside in this case. So that's that's what those look like. Yeah, I was just looking for, the literature where I read this. That's from the Brick Association. They talk about this in their technical note 23A. They talk about stone and masonry trims and whatnot, and they talk about the need to create a capillary break between that and the brick. So anyways, it is a good idea, so I'm going to leave that there. But like I said, it doesn't always happen. I've seen it where it hasn't happened, but I guess you never know what's in store for you, so why not just do the right thing? And pinning the top of this thing here, like you could just pretty much have a brick tie type scenario with a flange, kind of like an L angle flange, where there's an L coming out towards us here, and then you could anchor back in like that. So that'd be pretty easy to come up with something to pin the back of that stone there. And you want to think about accessibility there too. You didn't want to put it in a place where you could actually get it, but you could actually even have a threaded a bolt cast into the the concrete here, and then and then again have an aluminum plate or metal plate come off the curb or the face of the wall there, and then thread a nut onto there, something like that. Could work. I'm sure contractors would have some other ideas how to best deal with that, but you just want to give some solution to that's workable. And then there'd be like masons on site or whatnot that could give some suggestions as well. It might be a little bit easier. I think the important thing from the detail is more to indicate, something's required there. Let's figure out something. So you've come up with a solution. Is it the best solution? Maybe not. Like maybe, like I say, maybe a mason has the best solution to that, but something is required anyways. And now I was just contemplating that situation of, could somebody want to step over and step onto this? But I think we've kind of solved this problem because it's not going to be appropriate to attach this railing to the face of this veneer anymore, this concrete veneer, brick veneer. So I think what would probably end up happening in this case is, if we go to the picture, they actually ended up mounting it to the top of the floor slab, but I don't think that's a good idea either, to mount it to the top of our concrete here. So probably I would take the same approach that they have here, but just apply that to the face of this concrete curb right here. And so I won't get into the ins and outs of the actual, what the actual guardrail is, but maybe there's a base on it, or the post at every post. I guess I should do it like that, and there'd be posts in the background. But anyways, there'd be a connection back to, very similar to what they had proposed here, back to the curb there. That should work. And doing that just prevented people from stepping on top of our cladding. And I think probably what the best scenario would be to have a knife plate coming out from the structure here to a certain point, and then so let's say there's a knife plate coming out to here, okay, and then have another plate come off the posts and then actually bolt to the other knife plate, and that'll just allow someone to take the railing off one day and replace it. And again, so the idea I'm getting at there is something like this situation here, where there's two plates overlapping and then some bolts put through it. And actually, I wasn't really happy with the idea of fastening this railing to the brick there either. So this helps, that the railing would extend up, but there's really no need to attach it on the sides. There'd be enough attachment just at each post. The end post basically here would have a knife plate going back to the curb there, and you wouldn't really need to. You could just stop that there. Okay, let's look at some flashings here. So we're going to want a flashing underneath the door here, and we also got to think about how we're going to finish this surface here. We don't want to see the insulation, so it looks to me like they've just done a pre-finished metal flashing there just to cover up the insulation, which is fine. I don't have any issues with that. And then here, I'm just looking at the frame, and I can see an arrow here, so it looks like there's a weep hole right here in this frame system. So what I'm thinking happens there is probably the flashing wants to be something like that. So when it weeps out, it comes down the flashing like so. I've added a flashing down here. I don't want any water from above, basically in the more exposed area, getting into the cavity space of here. Let's try and keep that out. So any moisture that's accumulating up here, let's get it out of the system right here. So I put some through wall flashing there. And I think to finish this off here, looking at this, what I'd probably propose is that this come down like so. Just do it in one piece. I'm not 100% sure if the flashing goes into that point right there without having the manufacturer's literature, but if it didn't, you can extend it back, I suppose, and oops, and do this. But seeing that they have a weep there, I kind of suspect there's probably a place to tuck some flashing into, like so, with the intent of moisture not to get back into here, but again, maybe this extends back all the way back right here. The flashing is going to have to work around that knife plate, but that's just life. Some stuff like that happens. And I should mention here too that you could extend this flashing out onto this like so. It's all about looks. What do you want to see? This is a better solution for sure, to not let moisture accumulate on the concrete and have the drip edge here. But does the designer want to see that? Maybe not. So again, that's the ideal. This is often the outcome, though, just for that reason, that you don't want to see the flashing edge. You want to see the actual concrete. So again, there's always the ideal, and you just kind of you got to find the reasonable middle ground. Let's put it that way sometimes. Okay, so down here at the bottom of the brick, I'm going to add the through wall flashing. That's going to, any moisture that's behind the brick, we're going to get it out of the system right here through the weep holes rather than let it get down to the window head where there's a weak spot basically. So that's what the red line represents there. It'd be some through wall flashing. In this case here, I believe they've angled this knife plate for the purposes of then providing a resting point for the flashing to sit across potentially there. Quite often though, I mean, this is often done just like this right here, which I could actually show some pictures of here in a second. You just want to get a slope on that, and then yeah, you cut the insulation here on each side of that flashing. So I'll fix that up. But basically, there's that image right there. So different building again, but there's the shelf angle. Here's the flashing, and then we haven't got to the membranes yet, but it's going to overlap the flashing there. And so that's a common way to do it, which suits me just fine. Okay, so I fixed that up the way I like it. Next, we've got some more flashing here to deal with. Okay, I'm a little confused all the goings on here, but anyways, you'd have some flashing here. And again, just always picture yourself looking up at this. Okay, what am I seeing when I look up here? Do I want to see the underside of the steel angle? It's very common to leave it exposed. I suppose it could be stainless steel, but that wouldn't be very common to do that. You could paint it. But you don't want big gaps like this either, so you want to make sure that spaces like that are discrete. Let's put it that way. Okay, so let's put some membrane layers on here now. So because it's a fully outside insulated wall system, we would have an air, vapor, and moisture barrier membrane. Okay, and so we're going to want to get some behind the flashing. So I would have a starter strip here like so. Okay, let's draw it like that. And I've mentioned before that we're going to have actually, let me change my line type here. Okay, so there would be a starter strip put in, for the back dam there and on the door sill there, and it would overhang another layer here. So always do positive overlaps, okay? So you never want the next membrane to be on that side of the membrane or water can get down into there. So always show them overlapping in a positive way. The membrane could go in behind this bolted connection here. So this is kind of a self-healing type product. It's got some thickness to it, and it would be pretty reasonable there. You could also put some over top of the connection there as well, but for simplicity here, I'll just draw it like this. I've put some behind the flashing, and then what I'm going to do here is actually, what should happen here is let's drag this one down. When you want to show all these overlaps happening in your details. So it would be something like this. It would be happening on here. So what you're after here is, so this is your air control layer, this self-adhering membrane, which is, this product right here in this case. And so what you're after here is that it's overlapping the piece that's going behind the flashing, but yet it's also your moisture barrier, so it's shedding the water over top of the flashing. So you just want those overlaps to happen kind of like that. At the deflection joint here, I've just shown a reinforcing layer to go in there. And then this one's going to overlap that one. Okay, like so. Okay, so I've done the positive overlaps at the deflection joint here. And so this strip right here would just be like a little more flexible layer in case there was deflection there. Again, I think you'd have a pretty minimal situation here, but I've shown that. Oh, and by the way, actually as well, you don't ever butt the gypsum board right up against the concrete. Okay, there's always a bit of a gap there, and then you can just put a sealant in there. Okay, and just working my way down, I've just again kept my positive laps and done kind of the same approach. Overlap the membrane, overlap the flashing at all instances, and I've also put a strip here to line the rough opening of the door. So I've wrapped a starter strip there basically in the rough opening of the door, and I'm going to wrap that right around there So when the frame attaches, it's just against there. So that would occur on the jambs as well. And the head, I guess it's less critical on the head, but I would put it there nonetheless. And then also on the sill. Okay, so something else missing here is, this is a condo building, so apartment building. So at the very, very least, you'd have an acoustic mat put down there. So those, they come in various thicknesses and different types of products, but a cork board type thing, maybe 13 millimeters thick. And then you put on whatever your floor finish is. Of course, you can keep adding layers to get better acoustic value, but that'd be the standard, I guess, absolute minimum in a concrete structure. I would say would be the acoustic mat, and then the floor finish, if you're going to have a hard floor finish, especially. So the concrete structure itself, a 250 slab of concrete, you might think, well, that's got to be good at controlling acoustics, and it is from an STC standpoint. So from an airborne noise standpoint, it's pretty good. But from if you're walking on or drop something on the floor of a hard surface above, that sound will travel through no problem. So then adding the more layers up here start to help improve the IIC, which is the impact sound transmission. And then that becomes a whole topic of its own because, then you can put a drop ceiling in there and you could have like resilient channels on the ceiling. You could have hangers that are like resilient channels. There's all kinds of stuff from acoustic standpoint. So again, I'm just showing the bare minimum. I'm not going to get into that in this video, but there's all kinds of considerations to think about right there. And of course, here you'd also have probably a baseboard on here as well to finish that off. And one other thing I'll mention here too is, an important part of this is to ensure that you have, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8 full courses of brick. So that's an important thing to note on here is, you don't want any cut bricks. So you would want to make sure you dimension this properly to the size of that product. That is very, very important with brick, okay? Because you want to get 8 full bricks. You don't want to end up with 7 and a sliver of an 8th one or something like that. So you would actually put the dimension there and say, whatever the dimension is, 8 courses is a way to, that makes it very clear that's what that needs to be. Because what you don't want is stuff like this happening. Why on earth would you make a mason do that? If you work with the size of the product, so most standard brick, the modular brick is 57 high and a 10 millimeter mortar joint. If you work with that, work your way up, design buildings so you don't end up with cut pieces like that. Less waste, less labor. And anyways, I would say that, so the end result of this, greatly improved. It has the same appearance essentially as what they were after, I guess, in the design. But we got rid of that huge thermal bridge there. So there's, some thought process through that, but that worked out pretty well, I think. And the other thing it did too is, if you look here, I just kind of noticed this, is the floor slab wasn't perfectly straight. So then the brick started to get cut here, and I noticed that the brick are bigger on this end than that end. So by taking this approach, you have some more construction tolerance there as well to deal with that type of situation, or I guess, or to avoid that situation. Anyways, probably all sorts of other things that I'm sure viewers will come up with, but that's kind of how you work through a detail. That's the type of stuff you would show. Okay, we start with the structure, the primary structure and secondary structures, and then our substructures, and then we went through our thermal control layer, air control layers, vapor control, moisture control. We got into the looked at the cladding systems and is it a rain screen system or what, what's happening. You're being very accurate in what it is. We looked at the frame systems, how they work, and make sure that they're fastened correctly and have things to attach to, and so on and so forth. Thought about the railing. We didn't just draw a railing. We actually thought about, okay, is this going to be possible? Is there a better way? Maybe somebody else on the team will come up with a better solution, but this is a solution that could work. And so this would be the level of information that you would want to show in any detail, as a minimum, I would say.